we'll go ahead and give it over to Dr. Basil, who's been giving lectures since 1974, and this is actually, this avian influenza slide program was actually part of his lectures at Green Mountain College. So he's been doing this quite a long time, is really an expert on this subject, and it's quite fitting if you know that there is a current outbreak, a particularly bad one this season, all over the place. And so we will give it over to him to let him get started on his presentation. So I'll stop my screen and his slides should pop right up and be good to go. It's all yours, Dr. Basil.
Okay, thank you very much. And thank to all of you here today to hear this presentation. I'm not able to, let me just, Jim, I'm not able to advance the slide. Let's try this. Ah, here we go. Okay, we got it.
There you go.
Okay, yes. So this is the star of the show over here in the influenza A viruses. You can see the 80 to 120 nanometers diameter, and a single strand of RNA divided into 8 segments. This is very important point to remember. The genome encodes for 11 known proteins, and these 11 known proteins, some of them are what determines the pathogenicity of this virus. So this is a little schematic of an influenza virus. You have the envelope with surface proteins, hemagglutinin and neuraminidase. The hemagglutinin is a surface protein that will combine with the receptor on the host cell, sort of a key in the lock situation, a knock on the door. And if the key fits the lock, the virus will be admitted into the cell. The neuraminidase is another surface protein. This one is involved with guiding the virus through the host cell, and also in releasing the virus from the host cell to then go on to another cell, another host cell. And the inside, you see the 8 segments of the RNA strand. So there's classified 16 of these hemagglutinins and 9 of the neuraminases. On the this works nicely here. So here, the aquatic birds, these are the what they call in epidemiology the reservoir. This is where the virus lives and works and plays and evolves in the aquatic bird population. Then this can be transmitted to domestic poultry. And oh, and by the way, you'll see able to see here that aquatic birds contain all 16 of the hemagglutinins and all 9 of the neuraminases. Now, as we go to the viruses becoming picked up by other species, such as domestic poultry, where a little bit fewer, there's only 13 of the hemagglutinins in here, but all of the 9 neuraminases. Then from domestic poultry, we have quite a few in the domestic pig. You'll see the significance of that shortly. And here with the potential for transmission to humans, if the hemagglutinins fit the key to the lock of the human epithelial cells. But notice that the virus has also colonized marine mammals and the turkey, which of course is part of domestic poultry and really should be up in this area here. But more recently, we have now a influenza in horses, from which has evolved the influenza virus in the last several years in dogs. And experimentally, the dog virus can be infectious for cats. Interestingly, the domestic ferret is the laboratory model for the study of influenza viruses, because their receptors on their cells really fits the key for a lot of the hemagglutinins, especially the ones that infect humans. And in fact, when I was in practice, when someone would come in with a sick pet ferret, just running a fever and not eating and really not much else in the way of signs, one of the first questions I would ask the owner is, has influenza been in any of your family members? Because the ferrets are so susceptible to it. They're even more susceptible than humans to human influenza. This is a CDC infographic on the transmission. You have direct contact transmission with birds. And here's a person handling the bird and mistakenly touching his face. Contaminated surfaces, what they call fomites. This could be litter. This could be the places the birds are feeding. Another way of contacting it is basically similar. In other words, hand contact, and one touches one's face. And it can also be in the air from the scratching of the birds, shaking the heads, and the droppings. I always encourage people, if they have backyard poultry, if you're going out to clean out the coop, wear a mask. So let's go through the way this virus invades the cell, because it's very important to understand how it evolves by looking at this. First, the attachment of the virus, the hemagglutinin, and this is the receptor of the cell here. It's these glycans, these are basically sugar molecules here, polysaccharide, sialic acid, attached to a protein in the cell membrane. So if the hemagglutinin fits this sialic acid receptor here, then it's open sesame, and the key fits lock, and here the virus is surrounded by a portion of the host cell membrane. So it's like a Trojan horse now entering the cell inside this endosome. So it floats down in through the cytoplasm of the cell, finally reaches a point here, then at this stage where there's a change in pH. Notice the pH change from up here, and the envelope of the virus opens up, releases the 8 RNA segments that then are released into the cytoplasm of the cell right near the nucleus. These will then enter the nucleus. They will then take over the replication machinery of the cell, so that the host cell is now replicating these 8 gene segments in preference to anything else, and also the other viral proteins and parts of the virus. And it's therefore replicating viruses within the host cell. So what will happen then is these new viruses will bud off, or sometimes the cell will simply just die and rupture and release these viruses to then go on to the next cell and enter the new cell. So here is a question I'd like to pose. What do you think would happen if a host cell was infected with 2 different influenza viruses? Well, let's go back to our little scheme here. Instead of having 1 endosome, we would have 2, one for each of the 2 viruses. Get down to this point here where the change in pH occurs. The viral envelope opens up. The cell membrane portion here will open up. And now we'll have not 8, but 16 viral RNA segments floating around and entering the nucleus to be replicated by the cell. And then after this replication takes place, now these 8 segments have to be repackaged up into new viruses. But there'll be a random assortment of these 16 segments, so that each viral cell can contain some gene segments from virus 1 and some from gene segments of virus 2. And this describes that. Here are two different influenza viruses into the cell, all getting mixed up, and now we have a new virus, a hybrid sort of these first two viruses. And this is called genetic shift or reassortment. So overcoming the species barrier. They have genetic drift and genetic shift. Genetic drift is our typical concept of gene mutation. A high proportion deleterious, it requires many mutations to get a change in phenotype, and it's a really slow process. However, the virus has that reassortment process, the gene shift, which becomes a major jump where a whole package of new genes can be reassorted into these cells. Now, these also can be many deleterious, but the point is it's a rapid change in the virus. And this is the reason that these RNA viruses, this particular RNA virus, can mutate and change, attach to new species. Very, very difficult to find vaccines for a moving target like this. It's a major reason that these influenza viruses are such a challenge to the poultry industry and in human medicine. So here's kind of the overall picture of the ecology here. We have our wildlife reservoir of persistence of the viruses amongst birds. The birds are not themselves, this is the low pathogenic, they're not themselves really sick with this. These are quintessential avian viruses, very well adapted to their species. And they're traded around in the environment of water. These viruses can live for a year in 60-degree Fahrenheit water. So very, very easy for the viruses to infect different birds. You can have different viruses infecting the same bird, and these viruses are reassorting and changing all the time. Next would be adaptation to domestic poultry, and then to the pigs that would be on the farm. And then, of course, the final step is spillover into human disease. And zoonosis is the term, or zoonotic disease is the term for diseases transmissible from animals to humans. So this is ground zero, China. Poultry viruses circulating constantly in China. And you can see all of these from H1 to N11, all present here in each of these provinces to a certain extent. These pie charts all indicate which of these hemagglutinin varieties are present in that particular location in poultry. So the purpose of this slide is to emphasize how China is really the hub of virus evolution in terms of influenza. It's the poultry and the wild birds are circulating these viruses all the time. Rice paddy, they have a very interesting way of earning a living and maintaining a good food supply here. Of course, you've got the rice and the rice paddies. Most of these farmers have a flock of domestic ducks. And these domestic ducks are turned out into the rice paddies from time to time to eat the bugs that would normally prey upon the rice. Then they're herded back into the barnyard. And you can see in this picture, there's lots of different colored ducks there, some of which are wild ducks. So here's where the wild reservoir meets the domestic ecosystem. In these rice paddies, with these ducks floating around together, defecating in the water, eating little things in the mud and on the plants. Also, when rice is harvested, whatever rice grains are left over floating in the water, they turn the ducks back out in there to eat that all up. And so it's quite an efficient and sustainable system. The ducks and the rice all giving the farmer access to food. But then what happens is the ducks go back to the barnyard where they interact with the pig. So now we have our link with a mammal. And if the hemagglutinin is compatible with a mammalian sialic acid surface protein, that's where the key fits the lock. And we have an avian virus becoming combined with a virus that's adapted for mammals. And that's why the pig is referred to as a mixing vessel, because this is where this dynamical system can take place and where can emerge a mammal adapted avian virus. Qinghai Lake in the Tibetan Plateau is a very key focal point for virus evolution. This is a major stopping point or a stopover point of migrating birds. And here's a few of the cast of characters that come through this lake. And they come through this lake by the hundreds of thousands. Here is the Central Asian flyway from India through Mongolia and then a breeding area up here in Russia. And notice this extends to, as you'll see in a moment, this extends over into Alaska. But here's Qinghai Lake in its crucial spot right here on this flyway where these thousands of birds congregate, stop over, they trade around their viruses, and then move on to new territories and bringing the viruses with them. This is the intercontinental spread of avian influenza takes place along this line, but here I'm enlarging it. This is a fairly recent study that I found, enlarging this graphic to include the continent of Europe as well. So here is the wintering sites for these water birds, and we're talking here about ducks and geese and swans, the Anseriformes, and the Charadriiformes, which is the shorebirds, gulls, terns, sandpipers, plovers, those guys. So they can migrate north for their breeding sites, where then they can then proceed down when they're going back down south, they can proceed down to North America through the Western Flyway here, or into Western Europe through that flyway down through there, and bringing the viruses that they have traded around with them. And here's the North American flyway, and the incursion point for these viruses for North America is up here in Alaska, and you can see by this graphic how these flyways overlap, so that birds in Alaska that contract these Asian viruses, it's pretty much all over North America in just a year or two as these birds cross each other's path and they mingle. And indeed, the U.S. Geological Survey since 2006 has been conducting surveillance of the birds in Alaska. And here's a technician taking a pharyngeal swab. They could take cloacal swabs also, because the viruses are shed not only in the feces but also in the pharynx. But apparently, according to a study from 2006, the virus will survive and be transmissible longer in the pharynx than if they took the swab from the cloaca. So the preferred thing is to take pharyngeal swabs and get those into virus tissue culture, isolate the virus, determine the H and the N, do all the sequencing to determine what new viral variations are on the doorstep of North America. So Alaska is what they call the incursion point for the avian viruses into North America. Now here's a little interesting side note. the plateau pica. This species is a keystone species. It's kind of like our prairie dog out west, where it's a very, very important link in the ecosystem. And they have actually isolated some avian influenza viruses from these picas up on the Tibetan plateau. And it's an area of research right now as to what, if any, part they play in the epidemiology of these viruses. It certainly, to me, would seem very possible. This would be a very good way for selection for viruses that have affinity for mammal sialic acid receptors, and setting the stage for the potential for pig infection and possibly human infection. So the plateau pica may actually be a very important part of the natural cycles of influenza, but time will tell. Another way of spreading of influenza viruses, other than the migratory birds, is the live markets in China. And there's, of course, been a lot of publicity on this with the early stages of coronavirus as well, that these are very, very common in Asia, and they are a very efficient way of transmitting avian viruses to people. Another is the worldwide trade in day-old chicks. China supplies many countries in the world the factory farms with day-old chicks, where they ship them out, and as you can see, by the hundreds, to farms that then will grow them up and put them to the markets in their particular countries. So this is an easy way for the day-old chicks to come with viruses as well. And one reason why sometimes we'll find influenza popping up, like in the middle of Africa, and traced to, however, day-old chicks shipped out of China. All right, this slide may actually be the most important slide of the talk tonight. The drivers of emerging influenza viruses. The worldwide loss of wetlands. As wetlands and lakes dry up because they are drained for farming purposes, or now with climate change drying up because of lack of rainfall, it means that these migratory birds become concentrated on fewer and fewer lakes and fewer wetlands. So it's going to be a much more efficient transmission of viruses when there are just so few choices for stopovers on their migration route. And large poultry farms, that is the factory farms, are on these migration flyways. The international trade in poultry, as I mentioned, day-old chicks, but also sometimes there's trade in adult birds too. Smuggling of birds for the pet trade, that's another one. We see this with Newcastle disease as well. This is something that I wish would end, but people seem to have the vanity of something pretty that should be in the jungle and take it in for a pet, but can bring in the virus as well. And climate change, migration patterns, rainfall, cultural practices, such as the wet markets. Another problem we see is cockfighting, which for certain ethnic groups is a common cultural practice. And birds are transported around on that basis too. I had people come to my office with requests for health certificates to take their chickens to Nicaragua or Puerto Rico or other places. And I, in my innocence, thought, oh, isn't this nice? He's really attached to his birds, to his chickens. Well, it turns out that these were award-winning, well, not awards, but bets, winning cocks that were fighters. And there was a financial incentive to taking these birds back to their original villages. So cultural practices do have a part to play in this as well. Okay, now domestic chickens. So they classify these viruses not only by H and N, but also whether they're low pathogenic avian influenza, LPAI, or high pathogenic avian influenza, HPAI. The low pathogenic is the vast majority, and these are mild signs. In wild birds, there are no signs. But with domestic chickens, domestic birds, very mild signs. Usually it's just a decrease in egg production. And then that bounces back up once the bird's immunity rids itself of the virus. The high pathogenic, that's a different story. Now these different manifestations of the virus, this is from one of the parts of the 8 gene segments. This has nothing to do with the envelope proteins. These are proteins that are encoded by those 8 gene segments inside the virus. And this can be sudden death. Person comes out one morning and all the chickens are dead or dying. Very severe signs, 50 to 100% mortality. Here is a lung of a chicken, and it should look like this little pink border here. The whole thing should be a nice pink color. Instead, this is dark red. It's consolidated. It's very congested, and it's reflected in the fact that this comb, there's wattles here, and the comb are very dark in color. It's not getting enough oxygen into the system, and the cells, they call these cyanosis is the technical term for that. And yes, some of them some birds just show sudden death. Now here's something relating to wild birds. Now this is an H5N8 outbreak in South Korea, 2014. And this is a Baikal teal. Notice the position of the bird. First of all, he's very weak, down on his hocks, as we say. The head position, tilted to one side, and the beak is down. We call that torticollis, showing neurological signs, in other words. And being a pathologist at heart, I couldn't resist showing this part of it. Here we have the heart showing this little hemorrhages here, and this white area is necrosis with death of cells. This is a lung, believe it or not. Here's a somewhat normal looking pink, but very consolidated here in this area. This is the pancreas. It also shows hemorrhages here and some white areas of necrosis. Actually, the influenza virus can hit kidney, liver, spleen, just about any organ. You get that HPAI, and it just wreaks havoc throughout the body. Now, this is from the same paper where they did necropsies and analysis of 771 bird carcasses that were collected. And these were most of these were dead birds. Some were live birds, like that teal. But I'm showing you this to illustrate 2 points. One is that the same appearance can actually indicate any one of a number of different infections, not just avian influenza. In terms of this study of 167 birds, 167 birds out of 77 actually had high pathogenic avian influenza. So that's 18.5%. The rest had these other things, different bacteria and fungi, and this fungi would be aspergillosis. Whoops, get back here. And then non-pathogen causes, agrochemical poisoning, gunshot trauma, miscellaneous, putrefaction. That just means the birds were just too decomposed to really show very much. And of course, the old unknown diagnosis. Unfortunately, that happens too many times. So what I'm trying to illustrate here is that even in the face of an active outbreak, out of 771 birds, only 18% really had influenza. The second reason I'm showing this is for the rehabilitators in the audience, and that is I and many other veterinarians try to emphasize we must set up a differential diagnosis when a patient comes in, and we're figuring out the clinical signs and symptoms, and make a list of a differential diagnosis and start ruling things out or ruling things in a very systematic way, with testing if possible, if other parts of a physical exam can be done. So a differential diagnosis is something that we preach to rehabilitators to concentrate on, rather than make a snap diagnosis once a bird is in, and treating accordingly without considering other possibilities. To this list, I would add also botulism can show the signs of limp torticollis and limberneck, as they call it. And I would also suggest that people consider getting veterinary support to do some testing, if at all possible. Try to rule out things in a systematic way. Okay, now the transition from low pathogenicity to high pathogenicity, that's an actual mutation. So that's genetic drift, not shift. But this happens, notice, in the agricultural setting. Mutation HPAI happens here, not in the wildlife. Now, the wildlife can pick up HPAI from these birds, especially once they contaminate the environment. But this is a mutation that occurs in the agricultural setting. And the reason is those factory farms, where you have overcrowding, poor hygiene, and certainly poor animal welfare. We should really do away with factory farms, but they are a hotbed of disease. And of course, these birds are challenged also with being on constant medications, constant antibiotics to promote growth, as well as to try to control the bacterial diseases that are rampant in this kind of husbandry. The typical response is depopulation quarantine. And something like, I don't know, 70 million birds have been destroyed worldwide from the current outbreak of the H5N1 virus. So here is the story of our H5N1 virus. We started out here with an H5N1 back in 2005. Actually, the ancestor of this one goes back to 1996. So the current outbreak of avian influenza really has a 25-year history. And you can see through all the permutations it goes through here in terms of wild birds as well as domestic birds, and getting down to the H5N8, which we saw in that Korean study, and then the H5N6, which is what we have going on the predecessor of the virus that's going on right now. So you can see how this evolution occurs, all with the reassortment of these gene segments. And what we're looking at here is about a half a dozen instances of gene reassortment between 2005 and 2015. So the H5N6, it's sort of hidden here on the side, but started out in China, and there were 28 human cases. These were cases of people contracting the virus from their own poultry. Certain people have sialic acid receptors that are more adapted to the H5 than other people. But the point is, it comes from bird to person, not person to person. That's when we have our epidemics and pandemics, is when the virus learns how to go person to person. But migrating birds, as you can see here, brought this virus to Western Europe, where now it had become an H5N1. And this is the one we have right now, which has then moved on into North America. So there was one human case in England of someone who had ducks, I believe, had a flock of ducks, and he contracted this virus. Now, how's it getting to North America? Well, here we've got Europe, mainland Europe, and here's Greenland and northeastern Canada. This blue and this reddish purple, this is the range for the anseriform birds, the ducks and the geese. And our sandpiper range is this yellow, but the green is the gull range. And the gull is the link between the anseriform birds here in Europe and the anseriform and also the shorebirds here in Canada, all going through Iceland. This is the incursion point, as like Alaska was for North America on the eastern side of the Asian flyway. Here, it's Iceland is the incursion point for North America on this side, the eastern side of the Atlantic flyway. And the gulls pass it gull to gull and take this virus across the seas. There was a study done on the prevalence of the influenza virus done in these gulls. It turns out that the herring gull and the great blackback gull were #1. And they're the immature birds, the so-called brown gulls. We've all seen them at the beach, the gulls that are still in their immature plumage. Those young gulls, there's a 50% prevalence of influenza viruses in those birds. The adult birds, it's down to less than 10%. But you know, the young birds still have a developing immune system and very susceptible, and they are the conduit from Western Europe into North America, and that's what happened with this current outbreak of influenza virus, the H5N6. And this is another study showing that all roads lead to the gull, from the shorebirds to ducks, the passage of the virus, the probabilities. That's what these represent. These are Bayesian statistical probabilities. All coming into the gull as what brought it all over to our shores through Labrador and Newfoundland. So it arrived in the U.S. this year. This is a American widgeon, and a hunter harvested this bird in South Carolina, and the state did some routine swabs of that particular carcass. The bird, according to the hunter, was showing no abnormal signs, seemed like a healthy bird, but turned out positive for the H5N1 virus. And then in Indiana, in February, this virus showed up in the first commercial flock, being turkeys. So we were off to the races. And this is the latest map from the USGS. Commercial poultry are the red dots. The non-commercial, the backyard birds, are the yellow dots, and the incidents in wild birds, isolations from wild birds, are the green dots. So you can see it's pretty much gone pretty much across the spectrum of the continent, but you can kind of get really an impression of where the flyways are just by looking at the distribution of the incidence of this virus. Okay, finally, how we coping with this is having a biosecurity plan. Every person with collection of birds, be they farmers or aviculturists of some kind, they should have a biosecurity plan, which involves looking at your entry points from the outside world into your bird housing and having some form of control there. So what I'd like to do right now is see if I can play you a short video from APHIS, USDA, on biosecurity. And see if this will launch. Yes.
Is similar to what we use every day to protect ourselves from many human infections. We wash our hands and we avoid eating food that we think might be contaminated. We wash our dishes and avoid contact with people sick with flu and cold, because we know even a handshake can transmit germs from one person to another. While we use personal hygiene
So
daily,
Basil, it sounds like no one can see the video. I'm just seeing a gray screen on my end at least.
are usually just
All right. Well, let me
inconvenient.
just. All right. Let's.
However,
I'm prepared for that
poultry,
possibility
some
here.
contagious diseases are
All right.
deadly and easily transmitted. Exotic Newcastle disease, or END.
Okay. Let's go back to this, and I have a few slides on biosecurity right now. We can look at. Okay. So wash your hands before and after coming in contact with poultry, and this, any birds, the collection of VINs or whomever or wherever. Washing hands is just soap and water. It doesn't have to be anything, caustic or statistics and studies have shown that just good old-fashioned soap and water and just spending a few minutes just scrubbing your hands is just as good as any disinfectant. In fact, triclosan and some of these disinfectants actually encourage antibiotic resistance. So you're better off just go with just good old-fashioned soap and water. Clean, disinfect equipment. Don't share tools and supplies with other poultry owners. And here, define paths where trucks and vehicles, other equipment can travel to the area. It's that basic principle, identifying the points of entry of the virus and having methods of coping with that and preventing entry of viruses. And one of the ways is to scrub shoes and boots. This would be a disinfectant in here. Could be just bleach. It could be various quaternary ammonium compounds. Scrub off the mud as much as possible, and then dip into a foot bath. Or better yet, have boots that are dedicated solely for use in the bird area, so that when you come from the outside world, you put on those boots and you take them off when you leave the bird area. The same can be for clothing, dedicated coveralls that you put on before you enter the bird area, and that you leave when you leave them hanging on the hook when you leave. Okay, so I guess we're ready for any questions. What time is it? Okay, that's good. That's good.
Yeah, that's great. Thanks for that. So if people do have questions, feel free to unmute yourself and then ask your question. People can also enter it in the chat too if they have microphone issues, then I can ask it for you as well.
Hi, I have a question. What happens when somebody eats that infected poultry or meat, chicken?
I didn't catch that last part of that.
Like, what happens if somebody consumes some poultry that is infected?
Oh, well, if it's cooked, that solves the problem.
Okay.
So what your concern should be in are you preparing the food on what surfaces that can be disinfected, which would mean a glass or some kind of plastic cutting board, wood, it's porous. It's really hard to disinfect. And this is true of what you're talking about, even Salmonella or Campylobacter, which are actually more of a concern for food safety than avian influenza virus. But yes, attention to hygiene and the preparation of the food and the preparation surfaces, and avoid the possibility of cross-contamination from those surfaces onto things that don't get cooked, like vegetables, whatever. So, and this would occur. This would be for fish, anything, preventing cross-contamination, and having dedicated cutting boards for certain things.
Thank you. And that same is true for the eggs.
Was there a follow-up question? I think I might have heard to that.
I was just saying that same would be true for the eggs.
Oh, the eggs. I have not read anything concerning ovarian transmission of influenza viruses. So I don't think that there are other pathogens that can descend from ovary into the egg, and Salmonella is probably number one of those for you to be concerned about. But again, if you cook the egg, you've solved all those problems. And just and even in handling the eggs, it's possible that after all, the egg comes out through the cloaca, so there is a possibility of some contamination there. But the virus really doesn't live very long in a dry environment. It really needs to be surrounded by at least a film of a few molecules of water to stay effective. So I don't think eggs would be very much of a concern at all.
Thank you.
Perfect. There's a couple of questions coming into the chat. So the first one was, what kind of masks do you recommend to clean the chicken coops?
Well, what we're talking about with the mask is our particles. No mask will filter out a virus. You saw the virus was 120 microns, nanometers in diameter at most. The best mask only goes down to 300 nanometers. So if you've got a naked virus or a virus coated with a very minor, just a coating of a few molecules of water, it's going to go through the mask. What the mask is doing is keeping out the particles. When you're cleaning out the coop and you've got all that dust, which is basically aerosolized dry fecal material in the air, you need the mask to keep that filtered out. So the standard masks that people have been wearing and that are designed as masks, not a bandana across your nose. That's really just completely worthless. Or a piece of a T-shirt, something that is actually a mask, and and then you throw it away, and then a couple of months later, when you're cleaning out the coop again, you get a fresh mask.
Perfect. And so the next question was, can we get a copy of the CDC transmission poster, which I think was referring to your map of cases? And I did put the link in the chat if that is what they were asking for. I'm not sure if there's another poster you shared. But the next question for you then is, what precautions should the general public take when handling sick or injured birds? And they're asking in the terms of like fielding calls from the general public. They ask if gloves and proper hand washing would be enough.
Yes, I think so. If certainly you're out in the fresh air, so there's not too much likelihood of aerosol contamination there. So just the precaution of hygiene and wearing gloves would be excellent. Excellent idea. Now, in an indoor situation, in a coop, or a person is a rehabilitator and is giving the bird intensive tube feeding and in an indoor environment, something like a mask might be a possibility to consider because you're in an enclosed environment. But a member of the public that's rescuing a sick bird outside, wearing gloves, and then putting the bird into some sort of container to transport it to a rehabilitator. But the gloves would certainly be enough, the disposable gloves, and just throw them away.
How
Excellent.
severely, oh, I'm sorry.
Oh, go ahead.
How severely is this affecting migrating raptors, eagles, corvids?
I have seen no statistics. We do know that the eagles are susceptible. They certainly have been ending up in rehab situations. But I actually was very interested in this very question, and I tried to find some kind of a list somewhere published on the species that were most susceptible to this current influenza, and I cannot find one. So I can't really answer your question. I'd be very interested in the answer to it myself.
Thank you.
But we certainly know that the problem is with the HPAI, the different taxa or different species are so different. You can't predict. Certain species of ducks and certain can be devastated, and other species not. The mallard seems to be bulletproof, and the mallard actually is one of the main transmitters of the influenza viruses from Eastern Europe into Western Europe. So you just can't predict which species is going to be resistant and which not.
I have a question. Can you hear me?
Yes.
Okay, good. I am head of our Lakes and Streams Committee on Eastman Lake over in New Hampshire. And last year we had a case of avian malaria. One of our nesting female loon died, and the Loon Protection Committee was terrific and came and necropsied the bird. That is transmitted by a mosquito.
Yes.
And I'm wondering now, when we hear about the flu and the others, there's sometimes a challenge getting people to do necropsies of birds to determine it. And is there, I'm assuming we would not have any idea whether our bird had the flu or avian malaria unless it was necropsied. Is that true?
That's correct. Yes, necropsy would be a really the next step, but doing a good physical exam can give you a lot of information as well. And you've come to the right place. We have there's a gentleman here on the staff at VINS. Bren is becoming an excellent pathologist, and is actually studying avian malaria right now, but mostly in passerines. And does the necropsies, and we work together on a lot of these cases. So speaking on behalf of both of us, if you've got a fresh specimen that's not decomposed, boy, we'd love to delve into it.
Well, that's good to know, because a second bird was found a week or so later, not a loon, and due to the fact that our reporting protocol didn't work very well, we never were able to collect that loon. But one of the things was that they reported it to Fish and Wildlife, which doesn't do necropsies. And on the weekend, they say report it to the state police, who really don't care a lot about dead birds. So it is good to know that there is another resource nearby, because it was really, as you can imagine, we were all greatly saddened by the loss of our female. So, and there weren't many diagnosed in New Hampshire last year. I think it was only 2 or 3. So I'm glad to know that we have that available. Thank you.
Yeah, I'm a bit of a pathologist at heart, so I would be more than willing to make the trip over there to do necropsies.
All right, you've got a bunch of questions that came into the chat, so I'll try and run through a bunch of them. And
okay, I'll try to be brief.
Okay. So one question was, do we think it's going to get better, and how long till we think we're, quote, out of the woods?
Well, that's a really good question, and it's one that I had too. A doctor, let's see, I've got it here. At Tufts Veterinary School, professor was asked that question. Here it is, Jonathan Runstadler, Cummings School of Veterinary Medicine, infectious disease and global health professor, and asked that very question: what do we expect from this virus? And of course, he says, well, the short answer is nobody knows. But his best guess is that this virus will be around pretty much indefinitely. And I was thinking that was the same question that we asked about West Nile virus 20 years ago. My practice was at ground zero of the outbreak in crows. And I had people coming in with these neurologic crows right and left. At first, we thought somebody must be poisoning crows, but no, it was much too widespread. But here we are now, 20 years later, and the crow population has rebounded. And in Pennsylvania, the ruffed grouse population that was also decimated by West Nile virus has rebounded. But we still have West Nile virus around, and they still get the virus in the mosquito pools. They still find, and they're still in Suffolk County, which is where I practiced. Every year, there's 5 to 10 human cases of West Nile virus. So that's I think, a likely scenario. Its epidemic capacities will be diminished as the virus gets better adapted to its hosts, and the hosts also acquire more innate immunity to the virus. We won't be seeing the die-offs of poultry like we have seen, but some reassorted form of this virus will probably be around for an indefinite period of time. That sounds like what this professor was saying, and I would agree with it.
Okay, I'm going to combine a couple questions here. So what are symptoms in infected mammals / humans? And then asking about what is the risk of human exposure at slaughter? I'm assuming of poultry birds. And then would it be detected prior to that if the bird was infected?
Okay, I would say that slaughter, you should take all the necessary precautions to doing it out in the fresh air, not indoors if at all possible, where you don't have as much aerosol concerns. But wearing a mask would be probably a good idea, because you're dealing with body fluids and blood and feces, and all of these can be potential sources of virus. Of course, wearing gloves and washing up real well all the equipment. And of course, you're not going to be preparing for consumption birds that are sick, presumably. So if you've got a flock that's had some mortality, you better get diagnosis of that first before you consider using the remaining birds for food. What was the first part of that question?
Symptoms in humans
if
they're infected.
Yeah, well, influenza, it's I think we've all experienced influenza at some point in our lives, and that's what avian influenza would be causing in humans too. It's basically a respiratory disease, fever, and it's in that category of respiratory viruses.
Perfect. And then, so what is known about the extent in songbirds, if they can be affected? And then there was a question about bird baths as well. Should they discontinue bird bath?
Songbirds, I really have very little data on that. It seems like everything that's been published now has been mostly on raptors and the waterfowl, but I see very little on songbirds. which maybe is good, because if there was major mortality, someone would have discovered it and published it, or at least got into the internet some way or other on ProMed Mail. So there's I don't think songbirds are a group that's very susceptible to it, from going just by what's in the absence of what's in the literature. That would be my guess. As far as bird baths go, I would say I would be really more concerned about salmonella than avian influenza at bird baths and bird feeders. So just especially in the hot summer, you know, just hose out those bird feeders, and maybe every week or twice a week, get out there with a little bit of bleach and just clean it up, and then hose it out again, and just keep fresh water changed on those bird baths. But I think it's bacteria that are going to be your most concerned with that.
That's great. And I think the state of Vermont, at least, is recommending to discontinue bird feeding and bird baths and even hummingbird feeders, just to reduce congregation of birds. And Bren, speaking of Bren, chimed in that there have been a few songbird cases, but limited testing. So it's, I think, like you said, it's not as much of a concern, but definitely out there. And then I think I saw one more question.
And bear in mind also, you know, this is a moving target. These viruses are reassorting and changing all the time, so that a new spectrum of species can you know, crop up at any point.
I think I see two more questions, and then that's all that I see. So one was, I've heard that it's okay to let chickens out of their covered runs now because bird migration is complete. Is that correct?
Yeah, I guess so. I think, well, that is correct. The migration is complete. However, the birds that are here and nesting could still be carriers of influenza viruses. So you're letting your birds free range. I think if I had waterfowl, you know, ducks or geese, and a pond, and in that pond was attracted wild ducks or geese, I think that would be of much greater concern than chickens that are terrestrial and really don't get it from that kind of wildlife.
So follow-up question for the bird bath disinfecting. Someone asked, is 10% diluted white vinegar okay to use instead of bleach to clean?
Oh, sure. Yeah, I think white vinegar would be another choice. And there are many other, you know, disinfectants that are available that you can use that are commercially, you can get these at Tractor Supply and other places that supply farmers with this kind of stuff.
All right, so the last one that I see are parakeets affected.
Oh, citizen birds? I have seen nothing on citizen birds. So I would say that as far as we know, this is not a problem of citizens. But as you know, if I had, I would still practice good biosecurity on any captive bird. That is keeping the utensils and the water dishes and all that clean, washing your hands before and after handling the birds. So every domestic species needs a certain amount of hygiene and biosecurity. But as far as any reported cases of this H5N6 or H5N1 in citizens, I've seen nothing on ProMed on that yet. And that's, by the way, ProMed Mail is the site to follow, because they get reports of diseases in domestic and wild animals, and they post it every single day. So that's the finger on the pulse, is to go to ProMed. I do it every day. Go to ProMed Mail every day and look at the posting. There's only like less than a dozen. So it's not like a big expenditure of time, but you'll see what's been reported. Previous flu out, now that I'm thinking about it, there were previous flu outbreaks in China where magpies were affected, and mynas also were affected. So that brings us into the passerine realm. But that's not what this was in China for with a different virus. You can't predict which group is going to be affected and which not with these influenza viruses.
All right, well, that's all the questions that I saw. The one thing someone did mention that the CDC poster was one of the first slides you shared. So if there's a way you could share that with everybody, that'd be great. But otherwise, we really appreciate it and really, really great information.
Okay, well, that graphic on avian influenza transmission, it's published by the CDC. I'm sure you could go to the CDC website and easily find it.
All right.